kinematics and kinetics. So under kinematics, dia ada dua cabang, particles and rigid body. Same goes to kinetics. You will see that will cover for particles, also for the rigid body. Okay, particle and rigid body. Okay, and then last time I already explained, we already discussed a lot about the differences between the kinematics and kinetics. You also can read from this slide. Okay, yang mana kinematics basically concern on the geometric aspect of motions. Yang mana bila pasal motion ni, it's time dependent. Okay, so basically kinematics dia tak consider effect of forces, but then when we talk about kinetics, we still talk about determination of the geometric aspect of motion, but they also include the effects of the forces. Okay, right. So last time we also highlighted about the detailed definitions of the kinematics and kinetics. Again, okay, relates displacement, acceleration, and time without reference to the cause of motions. Yang ni dia ada relations existing between the forces acting on the body, ada relation the mass of the body and the motion of the body. Okay, so basically kalau yang untuk kinematics ni, kita betul-betul cari A, V and positions. Position ni we can put as, tengoklah pada OZ coordinate you. Kalau X coordinate you X, X lah. Kalau Y, Y lah. Kalau S, S lah. Okay, bergantung kepada you punya axis coordinate. Alright, but here we try to represent for the positions. Okay, but for the kinetics ni, dia akan melibatkan forces, accelerations. Okay, normally based on the main equations, it only involve with mass, acceleration and mass. Force, acceleration and mass. This one also will involve sometime with mass value lah. Okay, to define to clarify this is a rigid body or particles. Okay. Alright, then I will focus for first topic, first subtopic. First topic is about kinematic of particle. Okay, under kinematics of particle, there are several subtopic. Okay, under kinematic of particle, there are several subtopic. Yang mana first you will study about the rectilinear motion. Okay, yang mana yang current sekarang ni lah. Okay, rectilinear motion, and then you will study about motion of several motion of kinematic of particles. There are several subtopic. Apa ni? Kena canggih-canggih pun masalah juga. Kinematics of particles. Dia ada several topic. First is rectilinear motion. Second is about the motion of several particles and relative motion. Then final one is about curvilinear motions. Okay, so basically under kinematics of particle, there are three subtopics, which are rectilinear motion, motion of several particles, and curvilinear motions. Okay, so motion of several particles and relative motion ni basically it will involve under rectilinear motions. Okay, that's why you see that the punya sequence tu dia bukan pergi after curvilinear motion, dia after rectilinear motions. Okay. Right, so this is the difference between the rectilinear motion and the curvilinear motions. The difference is in terms of how the particle travels. Okay, so for the rectilinear motions, the particle as move along a straight line. For the curvilinear motion, they move along a curved line in 2 or 3 dimension. Okay, but as I said, for our syllabus, we just cover up to the 2 dimensions problems. Okay, right. So last time we already discussed about in order to study about motions. Okay, we learn first about how can we define the positions. Okay, when we talk about positions, position kena ada coordinate dulu. Okay, so coordinate ni it can be anything. Okay, coordinate x ini can be coordinate x, coordinate y. Okay, you boleh namakan dia sebagai s, you boleh namakan sebagai p, whatever lah. Janji you tahu itu adalah coordinate. When we said that is the coordinate axis, dia mesti ada origin. Okay, you have the axis first, axis s. Okay, coordinate axis s, and then you have the origin. Okay, once you have this system, then you can define the positions of the particle. Okay, so for this case, the position of the particle we define by R or S. R ni kita panggil sebagai position vector. S ni adalah skala. Apa beza position vector dengan skala? Skala ni dia tak menunjukkan apa-apa value, directions. Kalau position vector, dia boleh menunjukkan sama ada dia positif or negatif ataupun dia ke kanan ataupun dia ke kiri. Okay, so bila sebut vector je, you tahu dia mesti ada magnitude and directions. Place from one position to another position, you will be able to calculate the displacement. Okay, so to calculate the displacement, you can use this formula. Okay, I go very quickly for this part because we discussed before. Okay, I just want to do recap sahaja. Okay, so to determine the displacement, the formula is final position minus initial positions. Same thing. The formula still remain the same, cuma dia punya form je yang berbeza. This one is vector form, this one is scalar form. So kalau vector form, you kena make sure that untuk you nak buat subtraction ke, addition ke, multiplications ke, or divisions ke, you have to make sure you divide based on their own directions. Okay, tak boleh direction X bagi dengan direction Y. It cannot be. Okay, alright, and then based on the position, you also can calculate the total distance travel. But again, total distance travel here is not in the vector quantity. Okay, it's not in the vector quantity. It is a scalar. Okay, sebab kita talk about total distance, jumlah jarak. Okay, so jumlah jarak ni dia tak ada positif negatif. Dia tak ada sign negatif positif, dia always positive value. Alright, and then from here we start. Okay, we start to link with our topic today, which is rectilinear motions. Tadi kita baru determine position coordinate ataupun position. Bila kita ada position berdasarkan coordinate, kita panggil sebagai position coordinate lah. So position coordinate defined by positive or negative distance. Ni origin you ke kanan. Sebab kita punya axis sekarang ke kanan positif. So meaning that this particle is positive. But then for this case, position kita berada di selepas origin. Okay, so that means that you have negative positions. Okay, so this is how we define the position coordinate. Alright, but once we want to talk about motion, okay, because our focus is on motion. So bila motion, if you only have position coordinate, for example here you have position coordinate of 4 meter, ni negative 1 meter. So that is the coordinate, that's the positions, okay, the exact positions. But when we talk about motions, motion ni dia bergerak. Kalau macam ni dia tak bergerak, situ je kan. Sekarang kita talk about motion, benda yang bergerak. So bila dia bergerak, we have to record the positions of this particle at every value of time t. Okay, baru kita boleh analyze for the motions. Okay, so in the problem of the motions ni, to solve it, there ada dua conditions. Sama ada you solve it by given position first or you are given acceleration first. Okay, so if you're given x first, so meaning that the x function here ataupun x at every value of time t, okay, macam mana kita nak dapat, macam mana terhasilnya adalah dengan kita measure. Measure tu bermaksud you conduct an experiment. Okay, based on experiment, based on you punya research. Okay, you have measure the position of the particle at every value of time t, then you can produce this function. Or you also can express in the form of graph. Okay, yang mana you will have graph x versus t. Alright. So once you have this, okay, now we assuming that we have this data, then later on we can continue analyze about the motion. Okay, so nak study pasal motion, you mesti based on the time dependent. Tak ada time, you cannot study about motion. Okay, so once you have this function, then if I'm not mistaken, we stop at here. Okay, once we have the position function, then we can use it to calculate the velocity. But before we can go in detail, how can we calculate the velocity? We look first the definition of the velocity here. Velocity is a measure of the data rate of change in the positions of a particle. The rate of change in the positions. Okay, maksudnya perubahan in positions lah. So ni. Okay. With respect to perubahan time dia. Alright, so yang ni dia adalah time sebenarnya kat sini. Okay, in this part, you supposedly to have. Okay, at this position, dia adalah this one is t plus delta t minus t. That will give you delta t. Okay. Alright, so once you have this data, alright, you have the change of length and change of time, then we can calculate the velocity. Alright. So inilah conditionnya yang mana ada perubahan daripada P kepada P prime. Okay, dia ada change in positions. Berlakunya perubahan kedudukan. Okay. So from here then we can calculate two type of velocity that we call as average velocity. Velocity biasanya adalah during a time interval delta t. Okay, during a time interval delta t, maksudnya delta t tu ada very huge value. Okay, bukannya 0.02 meter second, not 0.012 second. No, kalau dia 0.0 something second, we cannot calculate the average velocity because very small value that will give you error data. Okay, so once you have very huge delta t, meaning that you are trying to calculate the average velocity. Okay, average velocity can be calculated based on change of position over change in time. Okay, then if you have very short time interval, then meaning that you will tend to calculate the instantaneous velocity. Okay, bila you ada melibatkan very small time interval, which is the t is close to 0. Okay, so how we can calculate it? We are using this dx over dt. Okay, dx over dt, where the instantaneous velocity is the time derivative of positions. Okay, the instantaneous velocity is the time derivative of position. Dia refer kepada slope dekat graph position tadi. Okay, daripada x and t. Okay, bila kita kira slope, macam mana kira slope ni? Macam ni lah kita kira slope kan. Daripada slope position tu sebenarnya akan dapat velocity value. Okay, this is a case when you have very short time interval. Okay, so this is our first kinematic relationship. Okay, in our study, okay, we are often apply or use kinematic relationship. Okay, in order to solve for the motions. Okay, so this is the first kinematic relationship where you can use v is equal to dx over dt. Okay, dx over dt will give you velocity. Alright, so velocity is also vector quantity. Okay, bila kata vector quantity, it has both magnitude and directions. Okay, it has both magnitude and directions. So bila kata the direction tu, dia adalah negative and positive value. Alright, so as you can see here, now this is our axis coordinate. Okay, so when you have positive value of the velocity v greater than 0, so meaning that it's travel, the direction of the velocity is to the right. Okay, if you have less than 0, it go to the left. Okay, the direction of the velocity tu dia beginilah. V less than 0, V greater than 0. Okay, and the unit, so don't forget the unit for velocity is meter per second. Okay, unit for the velocity is meter per second. Okay. Alright, so what else? Next, we also can calculate average speed. Average speed. Speed tu apa? Speed tu magnitude of velocity. Okay. Magnitude of the velocity we refer as speed. Okay. So speed ni dia adalah skala. Magnitude. Magnitude sahaja. Okay. Value sahaja. Okay. So then from the speed value here we can calculate average speed. Okay, bermaksud average speed ni dia tak ada lah positive negative sign tu sebab dalam bentuk skala value. Okay, so for the average speed here is equal to total distance travel over time interval. Okay, total distance travel over time interval. This is ni symbol dia, speed average. Okay, speed average. Okay, so as a conclusion, to calculate the velocity, okay, bukan average velocity instantaneous velocity we also can call, we just simply call as velocity lah, tak payahlah kita sebut instantaneous velocity tu. Okay, so for the velocity, okay, from the definition of a derivative, the velocity can be calculated using dx over dt by using first kinematic relationship. Okay, so how can we use it? So in order to use it, you must have the function of x first. Okay, ada function x yang kita dapat tadi. Okay, you nampak tak? Ini adalah derivative. Bermaksud you kena buat apa? You kena differentiate. Okay, we differentiate x, then it will give you result for the velocity. Okay, so this is a function of the motions for your particles. Alright, then once you have this function of the velocity, which is based on the time position derivative, then we can go to determinations of the accelerations. Okay, so what is accelerations? Accelerations is the rate of change in velocity of particle. Is the rate of change in the velocity of a particle. Tadi velocity, rate of change in the positions. Now for acceleration, dia relate to the velocity. Bila ada perubahan in velocity, then you can have the acceleration. If you have no change in the velocity, meaning that the acceleration is 0. So it is under equilibrium. Okay. Alright, and again, before we go into detail about how can we calculate it, then next we want to highlight about the second square, and it's also a vector quantity, bermaksud dia ada magnitude and directions. Okay, dia ada magnitude and directions. Okay, how can we calculate this acceleration? The acceleration, the time derivative of positions. Kalau tadi velocity based on the slope at the position graph, but then for the acceleration it's based on the slope at the velocity graph. Okay, so this is the slope formula. This is based on the mathematical calculations lah. But in dynamics, we call as another kinematic relationship that can be used to calculate the accelerations. Okay, so here in terms of vector form, you also can have in terms of scalar form. Okay, so basically for the scalar form ni maksudnya you ada functions lah kan. Okay, yang mana bila kata scalar form ni dia dalam one directions only. Okay, if you have only in one direction, you can directly use in terms of scalar form. If you have in more than one directions, okay, more than one coordinate, you need to use vector form. Okay, so scalar form and vector form ni kena tahu kegunaan dia waktu bila. Kalau scalar form ni digunakan apabila pergerakan tu in one directions only. Okay, alright. Kalau you punya pergerakan tu begini, where you have to resolve it. So bermaksud you kena menggunakan vector form. Okay. Alright, so for the scalar form, you either can directly differentiate from the velocity function, or you can differentiate twice from the position functions. Okay, so overall at the moment you already know two kinematic relationship. This is second one. Okay, alright, and then tadi kita kata apa? Acceleration is a vector quantity, so meaning that it has directions. Okay, not only magnitude, it also has directions. Okay, maksudnya dia ada positive and negative. Okay, so acceleration can be positive when you have increasing in speed. Okay, kalau you tengok dekat sini gambar rajah ni. Okay, mula-mula yang ni pendek, ini panjang. Dia nak menunjukkan dia ada increasing in speed. Okay, increasing in speed. When you have condition increasing in speed, meaning that your acceleration is positive. And the direction of the acceleration will follow the directions of the velocity. Okay? But if you have decreasing, nampak tak dari pendek ke panjang, dari panjang kepada pendek dia punya arrow tu bermaksud berlakunya decreasing of speed. Bila you speed decrease, bermaksud you punya acceleration you negative. Okay, so bila negative, kita tak panggil acceleration dah, kita panggil decelerations. Okay, and you have to bear in mind, you need to check the arrow for this. Okay, dia tak lagi follow direction of the velocity, dia sekarang dia berubah. Dia need to opposite to these directions. Okay, so this is the thing that you need to remember. Okay, bila berlaku sahaja deceleration, automatically directions for your acceleration should be changed, not follow the velocity directions. Okay. Alright, so from the definition of a derivative, A can be calculated using dv over dt or d2x over dt square. Alright, so to use this, you must have the velocity function first. After you have the velocity function, then you apply this kinematic relationship to get the acceleration function. Okay, so from this acceleration function, you can define any positions of the particle at any value of time. Okay, by using this function, you can determine the acceleration at any value of time. Okay. Alright, so that's all about the determination of accelerations. Now, let's look in overall. Okay, so for the rectilinear motions, by given the position first where you measure it through your research, through your experimental work, okay, then you can produce this function. Okay, once you have this function, which is data in terms of position with respect to time, then we can use it to determine the velocity. How can we determine the velocity? We are using this kinematic relationship, dx over dt, where you have to differentiate x to get velocity functions. Okay, and then once you have the velocity functions, again, we do another differentiations. Okay, we differentiate v function to get acceleration, or you can differentiate twice from the position functions to get the acceleration functions. So once you have these three functions, so you can easily draw these three graphs. Okay, how can we draw this graph? By substituting value of t. Gantilah apa-apa value of t dekat situ. Okay, for example here, based on this function, okay, they ask us about what are x, v, and a at t equal to seconds. So you substitute lah t equal to 2 seconds in each equations here. Okay, once you substitute into these equations, then you will see that x equal to 16 meter, v is equal to 12 meter per second, and a equal to 0. Okay, and as you can see here, it put this statement. Okay, so in motions, okay, there the standard basic concept that you need to remember. Okay, the basic concept in motion is V max occurs when A is equal to 0. Okay, whenever you find that the particle moving with 0 accelerations, meaning that your V is V maximum and it is a constant. Okay, V adalah V maximum. So when A is equal to 0, V adalah maximum. Okay, and the slope of the velocity curve is 0 at this point. Because we know that A ni berkait rapat dengan slope of the velocity. So meaning that bila A ni equal to 0, bermaksud slope dekat sini adalah straight line. So tak ada slope lah. Okay. Alright, and then dia boleh nampak kat sini ni 2 kat 2 meter. Sorry, 2 second. At 2 ni A equal to 0. Ni V is V maximum. Okay. And then next, dia kata apa? What are X, V, and A at T equal to 4 second? Now dia substitute pula dekat setiap function ni dengan T equal to 4 second. When they substitute it, then they got X equal to X maximum equal to 32 meter. How do we know? Later on we will discuss about it. And then you get V is equal to 0 and A is equal to negative 12 meter per second. Okay, how we get X is equal to X maximum? Due to the velocity value. So once your velocity value is 0 here, okay, you will see that the position will be the maximum. Okay, so this is the basic concept that you need to understand. Right, when we study about motion, A0, V is equal to V maximum. V0, X is equal to X maximum. Okay, this is the basic concept that you need to know. All right, whenever you solve the problem, you need to remember this. Okay. All right, so far, do you have any question? Basically, that's all. How can we determine the velocity and acceleration by given X functions? Okay, ada soalan?
Tak ada, madam.
Tak ada? Okay. All right, now if you have no question, try to answer this question. Okay, I give you 30 seconds only. Give your answer in the message message room. Okay. Please read the question carefully. Apa yang false tu? Okay, mungkin you boleh begitulah. Jawab, dia tanya what is true about the kinematics of a particle? Give the answer A, B, C, or D. Okay. Lagi mana? Baru sikit yang menjawab ni. Yang lain mana? Terbaring atas katil ke? Dan kenapa attendance hari ni 29 je Almost 9 students not attend for today's class. Di manakah mereka? You all tak tahu ke? Ha? Siapa kelas rep untuk kelas 4C5?
Saya, Doktor.
Ha. Kawan-kawan semua ada ke tak ni? Cuba check sikit. Okay, I nak you kasih I nama siapa yang tak datang hari ni sebab ada 29 sahaja ni. Dan siapa kelas rep untuk 4A? 4A ke panggil? 4A4, sorry. 4A4.
Me, madam.
Siapa Mi tu?
Muhaimin.
Ha, Muhaimin. The same person. Okay, Min.
Yeah.
I want you to find who is not coming for today class. Okay? And then I nak both of you share me the name in the group. Jangan tak personal. Share in the group. Okay?
The list of attendance or the person who missing today.
Yes, exactly.
Okay.
Okay, Doktor.
Alright. So, yes, the answer is B. Okay, the answer is B. Let's reload together. Alright. First, the velocity of particle is always positive. Why is not right? Kenapa dia bukan always positive? Kenapa? Ha? Sorry, I can't hear you clearly. Kenapa dia bukan selalu positif? Kenapa?
Dia vektor.
Sebab dia vektor. Sebelum vektor, dia ada direction kan, ke kanan ke kiri. Bila kanan ke kiri tu dia adalah negatif ataupun positif, right? How about the C? What's the true statement here? What is true statement for C? Penat I tunggu you all ni. Saya panggil nama.
Position particle zero, velocity to kalau velocity to zero, position of particle to maximum.
Okay, ni sepatutnya kena maximum bukan zero. How about the last one? Nurin Najla. Mana Nurin Najla?
Saya, Doktor.
Apa kesilapan jawapan D tu?
Sebab kalau velocity tu maximum, patutnya acceleration zero. Tapi velocity dia maximum. Tapi ni tulis velocity dia kosong.
Okay, so sepatutnya adalah maximum. Okay, good. Alright. Any questions so far? Ada soalan sebelum I go to the next part? Masih lagi di subsection yang pertama kita ya. So tadi apa yang kita belajar? We learn about to define velocity based on the first kinematic relationship which are dx over dt, which mean you must have the position function first. Where this position function should be as a function of t. Okay? Once you have the position function of t, then you can apply this kinematic relationship to get the velocity functions. Okay? And then once you have the velocity function, which is this is function of t, okay, then we can get the acceleration functions. So the acceleration function can be calculated based on the second kinematic relationship, which is dv over dt. Will give you a as a function of t, where you have to make sure v ni mesti function of t jugalah, baru you boleh differentiate with respect to t. So as you can see here, nampak tak flow dia? Dia melibatkan pengiraan dalam bentuk differentiations. Okay, from X to A, you have to differentiate. Okay. Alright, now we want to go to the second case. Yang mana, again, we still talk about to determine geometric of motion. Position, velocity, and accelerations. Okay, kalau tadi kita start dengan given X. Now, is a case where you are given A. Okay. Kalau X ke A tadi, kita differentiate. Now, kalau A ke X, what should we do? Dalam matematik punya konsep? Kita kena integrate. So, how can we integrate it? Okay, before that, you need to know if you are given A first, you kena tahu A ni boleh diberikan dalam bentuk 3 different classes of motions. Okay, A ni can be expressed in 3 different functions. Where the first one, acceleration given as a function of time, acceleration given as a function of positions, and acceleration given as a function of velocity. Okay. So basically, mana nak kita nak dapat A ni sebenarnya, mana datangnya function-function A ni? Function-function A ni sebenarnya dia akan datang daripada topik kinetik sebenarnya. Okay. Dia kata, we often determine acceleration from the forces applied. Okay, yang mana nanti later on when we study about kinetics, you will see that it involved with F is equal to ma. So A ni kita based on force applied. Okay, and once you have A, then we can do integrations to get V. We do another integration to get X. Okay, but the issue here is A here can be as a function of T. Okay, A can be as a function of T. A can be as a function of X. A can be as a function of V. Okay, nampak tak? Sebab dia relate dengan force. Okay, dia relate dengan force. Okay. Alright. So, kat mana yang kita boleh jumpa yang function yang melibatkan position dan velocity ni? Kalau you study pasal spring, you can see that it will involve with position function yang mana spring force is equal to Kx. Ini adalah positions. Okay, yang mana function ni melibatkan positions parameter. Untuk velocity pula macam mana? Macam mana waktu bila kita dapatkan force is a function of velocity bila you study about drag force. So drag force is equal to K multiplied with V. So here you will see that the function is as a function of velocity. Okay? Alright, so now you know that in general to get the functions of velocity and function of velocity and the position by given A, you need to conduct integrations. But what kind of function or equation that you need to integrate? Okay, so now let me see here. Okay, so please pay attention. Alright, now let me see how can we derive. Now we want to develop the velocity function and position function by given A functions. Okay, so if your A is a function of time, okay, in order to get the V function, VT functions, okay, now we want to get these VT functions, okay. To get the VT functions, what you have to do first is, ni, tengok dekat second column ni, dia kata apa? You need to get what is the kinematic relationship that can relate to the A as a function of T. Okay, we know that A as a function of T is equivalent to dV over dt. This is our kinematic relationship. Okay, so this is our kinematic relationship yang mana AT is equal to dV dt. Dan next what? Okay, daripada sinilah baru kita akan rearrangekan untuk menghasilkan satu equation yang boleh diintegrate. Okay, so from here we have to rearrange all these parameters that next can allow you to do the integrations. So what we need to do here, we have to bring whatever parameter yang sama tu kita kumpulkan tempat yang sama, which is here we have dt on the left hand side. Sebab kalau kita nak buat integration, kena ada derivative. Okay, so kat sini dua-dua derivative kat sini. So kita pindahkan salah satulah ke sebelah. Okay, so since that here we are talking about A as a function of T, so yang kita bawa adalah dt. So you akan ada equation dV AT dt. Okay, So when you have this kind of arrangement of equations, then baru you boleh buat integration sebab you ada derivative kat dua-dua sebelah ni. Okay. Alright. So now because we know that we need to do the integration to get V sebab yang ni dV bukan V Jadikan V macam mana? How can we change dV to V? We have to integrate. So letaklah integration sign. Okay. Nak hilangkan dV jadi V, kita kena integrate. That's why you see this. We put this integration sign. Okay. And then, of course, you need to put the limits. So the limit dia from where to where? From initial velocity. Ini initial velocity. Ini final velocity. Okay. And then yang ni, they are talking about AT dt. dt melibatkan time kan. So bila kita sebut initial velocity, t tu mesti berada dekat 0. Okay. Bila kata initial value, bermaksud dia berada di t equal to 0. And the final limit adalah dekat t. Okay. Alright. So once you have this, you integrate lah. Yang mana bila you integrate dv dapat apa? You akan dapat v not v. So yang sebelah ni I tak boleh integrate sebab I tak ada function. So I can remain 0t at dt. So what you can get from here, you akan dapat v minus v not equal to this. Alright, and finally we get the function v as a function of t equal to yang ini integration plus with v naught. So inilah function velocity you yang you dapat hasil daripada these integrations. But again, I would like to remind you yang mana on this part I tak ada function yang I boleh integrate, so I remain in integration form. Okay, so once you have function v, how can we get position functions? Okay, untuk dapatkan position function, kita tak derive daripada A. Okay, kita derive daripada V. Okay, to get position functions, when we talk about T parameters, okay, we derive it from the velocity functions. Okay, macam tadilah. Tadi kalau X ke V, V ke A. Ni kita differentiate X dapat V, differentiate V dapat A. Okay, but if we are talking about from accelerations to ke atas, okay, so you need to integrate A untuk dapatkan V, integrate V untuk dapatkan X. Okay, so this is something that you need to know. Okay, the flow. Alright, so to get the position function, you must have the velocity function first. Okay, once you have the velocity function, apa nak kena buat? Okay, so kita ada velocity function dan kita integrate lah velocity function tu. Macam mana dia boleh terhasil? Again, we do the same process. Okay, we do the same process yang mana now let's say we have V function. Then what we should do is we need to recall the kinematic relationship that related to the Vt, which is we have dx over dt. Ini masih lagi A yang pertama Alright, so now we have Vt equal to dx over dt. Okay, so what should we do next? We bring dt to the left hand side. So you akan ada dx equal to Vt dt. Okay, so from here we introduce the integration sign x naught to x, 0 to t, then you will get x function. X, the function of t, is equal to integration Vt dt plus with x naught. Okay, this is how we derive from A to V. Okay, from A to V, A to V, and V to X. All right. So we do the same process. Okay, when we want to derive from A to V, V to X, we repeat the same process but with different kinematic relationship. Okay, this is when your A is a function of T. Ada soalan so far before I move on to the next one? Any question?
No.
Tak ada? Cannot move on to the second one because we don't have enough time. Alright, so I stop here. We will continue for the A as a function of position and velocity next week. Okay? Is it okay? Because this one memang take time sikit lah. I nak explain. Alright, so tak ada soalan eh? If you have no question, I guess that's all for today. Thank you very much. See you next week. Assalamualaikum. Have a good day.
Thank you, madam.
Thank you, Megan.
Thank you, madam.
Madam.